if I'm not mistaken, we have two people left, Nick and Joe. So whoever wants to go first.
I can go. Can you hear me?
Yep.
So I'm going to share my screen. Can you see my screen?
Yes.
Okay, so I wrote a neural network program. There's this website which details how to. Can you see this web? Can you see this website? Can you see the browser right now? Hello?
It's just
No, we cannot. It looks like you're only
Anyways,
sharing one. Try sharing your whole screen.
share my whole screen. Can you see it now?
Yes, we can.
So there's this website which goes over how to make a neural network, and I've been wanting to go through this for some time. Anyway, so I went through this to implement the neural network, and I succeeded. Basically, what happens is we create a network, a certain amount of layers. So this is like a 4-layer network. It's got 3 input nodes, 3 output nodes, a layer of 4 nodes, and a layer of, we'll change this to 4 nodes. And then it wants to obtain these values, these 3 output values, 0.06, 0.1, 0.73. And right now, the input values are just random. And the weights of the network's set up like it's got weights and biases, and those are random. They're set up randomly. And anyways, so it goes through this process called back propagation. Well, what it does is it feeds the network forward and gets some output. And then it takes that output and feeds it back through the network through this method called back propagation, which are these 2 functions here. Propagates the output, and then it propagates each layer backwards as well. And to show this working, so it says the input is randomly selected right now. It's 0, some small number. And the output from the first run is 0.9, 0.9, 0.9. And the desired output, of course, is these 3 values. And so then it says what the error is. The error is 0.71. And then so it ran 10,000 trial. It ran this back propagation algorithm 10,000 times. And after running it 10,000 times, these are all the weights of the first trial. Like, this is what they look like. And so anyways, it ran it 10,000 times. And now the desired output is the actual output. And the error is extremely low. And anyways, these are what the weights look like now. They look different, but where I want to go with this is just general neural network stuff, pattern recognition and stuff. Right now, I only have one random input pattern, but I'm going to start feeding in certain patterns, and have I'm going to do like image recognition and all. I got all kinds of ideas. Well, for my game, I'm writing this game, but yeah, this is my neural network thing, and it seems to be working. So.
Okay, it's definitely a good demonstration of the concept of a neural network. It seems you've got that down. I'm just a little curious why. Were you having difficulty with inputs that were not random?
No, I could specify any input I want. It's just the input. I don't check against. normally with a neural network, you have input and you want to get a desired output.
Right.
Well, what I'm doing right now, I don't initialize the input and it still trains to get the desired output. So for any given input, random, it'll train it to get the desired output. But alternatively, I could specify um, any input I wanted and it would still train it for that output. And so in the future, what I'll have is I'll have a kind of output I want, and like say it'll be a boolean, which will say like is a number or is like a character, and then I'll have a series of inputs, and I'll in sequence I'll pass the inputs through and do like lots of trials on each of the inputs. The network will slowly get adjusted for all of those inputs. It'll either output is a character or is a number. That's how neural networks work. But right now, just to demonstrate the purpose, I'm not specifying a particular input. It's just random, and it ends up demonstrating the properties of the neural network just fine. I think.
It makes sense to me now. Does the weights themselves, they initialize random, but when the weights are adjusted, the adjustments are not random because they're
The weights and the biases start out random.
right.
That's so the state of the neural network starts out random, and all I have is this desired output I want. And so then through this process, this algorithm called backpropagation, I feed the output backwards. Like when the network runs, it's called feed forward. It's running forward. It's running from input to output. Well, so now this backpropagation, it takes the output and it runs it through the network backwards. It runs it from in, it propagates it towards the front. It doesn't change the input data, but it propagates it right up to the input. And while it does that, it uses differentials to change the weights, and the weights are changed with differentials. This is what the yeah. There's all this math involved in this backpropagation algorithm. But yeah, the weights are changed programmatically through this backpropagation algorithm each iteration. Like right now, it's set to do 10,000 iterations. And the more iterations you do, it reduces the error. The error gets reduced every iteration. Like I could run it like once or twice, maybe. I'll run it twice. So it says the error is 0.68. And the output it generated from running twice. It started out as 0.889748 and it ended up being 0.87. So it went down a little bit, but the error is still really large. And the more trials you do, the error reduces as the weights become more refined.
Okay.
And so now the output is close to 0.06, close to 0.1. It actually achieved 0.73. And error, of course, is a very small number now. Yeah, that's how that works.
So what is a sort of real world use case you'd use something like this in? Like if you were to apply this to something, how would you use it?
Well, my direct application to my game is I want to use neural networks to handle like pathfinding to some extent. So right now I have like agents, they'll be like moving around and they'll be like bumping into each other and bumping into trees. And my ultimate idea is to use neural networks to guide them rather than if statements, because if statements, it's wonky to figure out good logic on pathfinding with if statements. So I wanted to try using these neural networks. And the first step in getting them working is to train them with backpropagation. I wanted to figure out this backpropagation algorithm. Ultimately, I'm using something different. But backpropagation, for instance, is typically is the go-to way to train neural networks. It's using image recognition. It's pretty much the standard way to train all neural networks in general. Like if I wanted to write an image recognition program, like the person earlier, um, yeah, he's using back propagation to train his network. I think, um, but in that instance, like this, the input layer would be a certain size, like the size of the bitmap, maybe. Like we'll say a bitmap is maybe like 100 by 100 pixels, and then the output would be like it could be like a boolean. It could say, or it could be like a 10. It could be like a number 1 through 9 or whatever, and then there'd be layers, however many layers. And yeah, it would just run. It that's how it works.
Did I see that right? That your intermediate layers, you could just keep passing parameters and it would keep injecting layer after layer in there?
Yeah, the way this is set up, you could just put in as many layers as you want, as large or as small as you want.
Right.
I don't know how useful that is. I don't know.
Yeah, look at Russell and Norvig's book, the book that they use for everywhere, and it'll explain to you why you have some set amount of intermediate layers. You don't have to be excessive with it. You can actually get surprisingly good results with pretty few. But
Right.
yeah, hidden layers are pretty useful tactics to try to get a little bit more accuracy.